functions, set theory, domain and range. Okay. Question number 1 for the day. So you're given a function ln x minus 2 under root minus 5 minus x under root, and you have to find domain of the function, right? The options that you have are 2 to 5, 2 to 5, 2 to 9, 3.5 to 5. Give it a clue. Find the domain of the function. So when you do this question, I'm writing some properties जो आपको याद होना चाहिए. You must remember those properties well. The first property is that you cannot take ln of 0. Okay. The second property is you cannot take ln of any negative number. Right. The third property is that because of the first two, whatever comes inside ln, जो भी यहाँ पे आएगा, whatever comes inside ln, that must be strictly positive. Whatever comes inside ln must be strictly positive. So these are some of the properties that you have to remember for a log function. Now keep these properties in mind and then solve. So we understand that whatever comes inside the log function must be strictly positive. Therefore, x minus 2 under root minus 5 minus x under root must be strictly greater than 0. So you get x minus 2 under root must be greater than 5 minus x under root, right? You want x minus 2 under root must be strictly greater than 5 minus x under root. Just solve this inequality, right? Once you solve this inequality, whatever numbers you go ahead and you get, that will be your answer. Just solve this inequality. Okay. You can also go ahead and write this inequality like this. X minus 2 under root upon 5 minus x under root greater than, I'm taking it here, greater than 1. Right? And if I square both sides, x minus 2 upon 5 minus x greater than 1. And I can take this 1 on the other side. X minus 2 upon 5 minus x minus 1 greater than 0. So x minus 2 minus 5 minus x upon 5 minus x greater than 0. X minus 2 minus 5 plus x upon 5 minus x greater than 0. 2x minus 7 upon 5 minus x greater than 0. Okay. Now this is a fraction. When is a fraction positive? A fraction can be positive if both numerator and denominator are positive. A fraction can be positive if both numerator and denominator are negative. Under these two circumstances, the fraction will be positive. These are the two circumstances which you will go ahead and get. So solving the first circumstance, 2 minus x greater than 0 and 5 minus x greater than 0, x greater than 7 by 2, that means 3.5, and 5 greater than x, so x less than 5. So if I combine these two, I get that x should be between 3.5 and 5. That's the first thing. The second one that I go ahead and I get is less than. So I get x less than 3.5 and 5 less than x. That means this x less than 3.5 and x greater than 5. So there is no common region. There is no common region, right? So we understand that this is the right one. This is where things make sense to us. Okay. Now, one thing that you have to go ahead and you have to see is that can I include 5 or not? Can 5 be included or not? Right? Because when we wrote it in the decimal form, numerator by denominator, this is coming in the denominator. And denominator has to be non-zero. But since the actual function is this, so when you go ahead and when you take x as 5, you get ln 5 minus 2 under root 3 minus 0. That means ln of root 3. So you will get some answer for this, right? Root 3 is 1.7, so ln of 1.7. You'll get some positive answer for this, which is making sense. So yes, from the actual function, we realize that yes, 5 can be included in the function. Right? So yes, all of you are correct. The correct answer will be this. Now, why I went through such a long step? Why not just solve it here itself? Mane, you could have gone ahead and you could have done things here itself. But why take this fraction and why they take this in this way? Because sometimes you may get a wrong answer. Believe me. If you don't take fractions and solve like this, if you don't take one on the other side, if you don't use this mechanism, sometimes you will end up getting a wrong answer. So be very sure that you do it in the right way. Even though this may be a bit time consuming, but you have to do it like this. Okay, next question. So you're given a function, root x plus 4 minus x. Find range of function. You have to find the range of the function. And the options are, so 2, 4, 2, 2 root 2, 2, 3, and 2, 2 root 2. Find the range of the function. Domain range is something very basic. All of you, not only abhi ke liye, because you're doing masters in economics बाद में, all of you should know how to go ahead and find domain and range. माने इसके बिना कोई भी क्वेश्चन या आगे कुछ भी MA economics करना worth it ही नहीं है if you don't know how to solve range and domain. This is 2, 2 root 2, but in open brackets. So to find the range of the function, you can go ahead and you can find the domain of the inverse of the function. That can be one method which you can apply. Find the domain of the inverse of the function. So give it a try. How about others? Anyone? This may not be the only method. You think of something else. You have to think of the values of y that you can get. Simple. What is range? Range is the value of y that you go ahead and get. When you put certain x, what y you go ahead and what y you get, that becomes the range of the function. So just think about it. But this is root. So property number 1, we know that anything which needs to be plugged inside root must be non-negative. माने if I have to plug something here, अगर मुझे यहाँ पे कुछ डालना है, तो I cannot put anything negative inside the root. So here I have to put something which is non-negative. Similarly, if I have to put something here, I cannot put something random. I have to put something non-negative. So from here I get x greater than equal to 0 and 4 greater than equal to x. माने x greater than equal to 0 and x less than equal to 4. So first thing I have understood is that the domain of my function, it is between 0 to 4. जो x का values इसके अंदर डल सकता है, the values of x that I can go ahead and I can plug inside this function, they will be anything between 0 to 4 इसके अंदर. ठीक है, because what x I can put inside it, it's inside root, और root में I can only put non-negative values. अब आगे समझते हैं. Notice that since this is, this is a function which is having its domain defined between 0 to 4, I can check what values the function is taking at 0 and at 4. एक बार ये भी check कर लेते हैं. So second, if I check at 0 and at 4, root 0 plus 5 minus 4 minus 0. So root of 4 is 2. And at 4, so root 4 plus 4 minus 4 under root. That means 2 plus 0, 2. So we have got a very interesting fact. What interesting fact? माने my function looks something like this. कि it is defined only between 0 to 4. सिर्फ 0 और 4 पे defined है. और 0 पे इसका वैल्यू जो है वो 2 है, और 4 पे भी इसका वैल्यू जो है वो 2 है. So there are only two things that can happen with my function in between, right? If, oh, this balloons. Either the function can go like this. Either the function can go like this. और द फंक्शन कैन इवन गो लाइक दिस, ऐसे ही कुछ हो सकता है, ये दो तीन चीजें हो सकती है। माने द फंक्शनल वैल्यूज दैट विल हैपन, अगर वो ऐसा जाता है, दैट मीन्स द वैल्यूज ऑफ y विल बी अबव दिस 2, यहां पे ऊपर कहीं वैल्यू आएगा। अगर वो ऐसा जाता है, माने वैल्यूज ऑफ y विल बी, या तो मैक्सिमम 2 होगा या 2 से नीचे रहेगा y का सारा वैल्यूज, right? So what we can do in such case, once we have understood that at 0 it is 2 and at 4 it is 2, बीच में y का वैल्यू 2 से ऊपर है या नीचे है, वो निकालने का बेस्ट तरीका है, we find the maxima and minima of the function, right? So we go ahead and we differentiate the function. So if I go ahead, this is the last step, जिसमें you go ahead and you find maxima and minima of the function. For the derivative, you equate it to 0 and you get 1 by 2 root x is equal to 1 by 2 4 minus x under root. 2 and 2 cancels out. So 4 minus x under root is equal to root x. So you get x is equal to, you square both sides. So you'll get 2x as 4 and x will be 2. Okay, x will be 2. So when you will double differentiate the function, I'm leaving it to you, you will find out that this is less than 0. Because it's a root function, so I know. Because any root function, when you will be going ahead and you will be plotting it, it will come out like this, right? So we know how the root functions will look. So therefore, I know that it will be less than 0. Now, you find out the value of the function at 2. So when I find the value of the function, I will get root 2 plus root 2. That means 2 root 2. Right? 2 root 2. That means the function is attaining its maxima at 2 root 2. So what we have achieved now? We have achieved that the function is achieving its maxima at 2 root 2 and these must be the minimum values of the function. So all values of y lie between 2 and 2 root 2. So the answer will be 2 comma 2 root 2. This is how you can go ahead and you can solve this question. So usually whenever they ask you the range of the function, there are only 2-3 methods. Method 1 can be you draw a graph and check. Method 2 can be you find domain of the inverse of the function, which may not always be possible if the function is very complex. And method 3 can be you find the corner points, जैसे हमने अभी किया था, and maximum minimum of the function to know the value of the y. These can be the 3 ways in which you can go ahead and find the range of the function. Is it clear? Anyone, any other method you applied in this? Okay. So this is 1 by 2, x to the power minus 1 by 2, minus 1 by 2, 4 minus x to the power minus 1 by 2. You double differentiate it. So 1 by 2 into minus 1 by 2, x to the power minus 3 by 2, minus 1 by 2 into minus 1 by 2, 4 minus x to the power minus 3 by 2 into minus 1, because this is minus 1. So you get minus 1 by 4, x to the power minus 3 by 2. This is minus, minus, minus. So you get a minus 1 by 4, 4 minus x to the power minus 3 by 2. So there is a negative minus 1 by 4 which can be taken out common. 1 by x to the power 3 by 2 plus 4 minus x to the power 3 by 2. It's a negative, right? So less than 0. Okay, I'll zoom out. Let me know once it's done. SOBS is also fine. That's right. Can we take the next question? Is this even visible at this zoom level? Okay. So we'll go for the next question. Try this one, Find the range of fx is equal to 1 upon 1 plus e to the power minus x. 0 to 1, 0 to 1, 0 to 1, 0 to 1. Find the range of this. Range means the values that y will take. Okay. So think accordingly. Very easy. A, B, okay. So first of all, what we can go ahead and do is simplify this function. When you simplify it, you easily understand how this looks. So I'm going to rewrite this function as 1 upon 1 plus, because this is e to the power minus x, I'll get 1 upon e to the power x. So if I take common, it becomes e to the power x plus 1 by e to the power x. And this becomes e to the power x upon e to the power x plus 1. Now, once you have simplified this function, right? So the next thing is that you should know how these exponential functions look, right? Log or exponential ka graph should be on the tip of your mind, right? Tip of your head. So if I look at my exponential function looks like this. And if I look at my log function, my log function looks like this. right? That's why it's not defined at 0, because as this function goes, it's an asymptote at 0. Meaning you don't go towards 0. So when this is 0, you approach minus infinity. Okay. So we are talking about exponential function. Meaning here whatever value of x I would have taken, मैं x का कुछ भी value लेती, whatever value of x I would have taken, my y, so if I take any negative x, I can take negative values of x also, or I can take positive values of x also. कुछ भी value लूंगी, I will get my y, which will be here, which will be positive. So if someone would have asked me, giving this function, ki what is the domain of this function? Domain means what values of x I could have taken. So I could have taken the negative values of x also, या positive values of x. But the answer I would have got would be always a positive y. I would have, if I take positive x, तो भी positive y आएगा, positive x तो भी positive y आएगा, negative x तो भी positive y ही आएगा. I will always get y between this, right? So y will be positive. But now what has happened here is that this e to the power x is both in numerator and denominator. Just that in denominator it is plus 1. Mane, if I go ahead and if I put say x as 0, so I get e to the power 0 upon e to the power 0 plus 1. Anything to the power 0, we know what it is. It is 1. So I get 1 upon 1 plus 1. It means I get 1 upon 2. That means I get 0.5. It will always be a fraction. क्यों हमेशा fraction होगा? Because in denominator, whatever answer you get, you add 1 to it. So the numerator is always less than denominator. Numerator is e to the power x. Denominator is e to the power x plus 1. So numerator is always less than denominator. So numerator by denominator is always less than 1. Right? Now, we have understood that thing. It will be always a fraction. Now, the question that only stands to apply is that can it be 0 or can it be 1? Mane 1 and 0 will be included or not? Wahi पूछना है. You have to ask that question. And to answer that question, it will be 0 if the numerator is 0. So it will be 0. This will take the value 0 if e to the power x will be 0. But e to the power x is never 0. You put any x, you get y which is positive. Right? You get y which is positive. It is not cutting the x-axis. The exponential function is, when will y ka 0 ka matlab kya hai? It is that value of x. When y is 0, it means you are cutting the x-axis. So when you cut the x-axis, right, at this y is 0. And when you cut the y-axis, at this x is 0. So it's not cutting the x-axis anywhere, right? It's not cutting the x-axis. So numerator is not 0. It's some positive number. It is something here, some positive number. It's not 0. So it means since the numerator cannot be 0, you're not including 0. And for the denominator to include 1, agar mujhe yahan pe, if I need this to be 1, denominator, if I want 1 to be included, mane I want numerator to be equal to denominator. Tabhi to fraction 1 banega. So I need e to the power x equal to e to the power x plus 1. Right? This is what I need. But is this possible? No. So it means 0 and 1s will not be included. Right? So all of you who answered it as A, that is the right answer. Okay. Why B? Why have you answered it as B? Why will 1 be included? It won't be included. Now, for 1 to be included, numerator and denominator have to be equal to each other. And that's not possible here. Right? For numerator and denominator to be equal, the denominator is getting plus 1 added to it. Okay. So next question. So although it's a limit question, I'm just including this here because if x is 0, isn't it 1 by 1? No, I just showed you, no? If x is 0, this is this function. Anything to the power 0 is 1. So it will be 1 upon 1 plus 1. That means it will be 1 by 2. Is it clear? Not always. Not always that will happen. I mean, just specific questions give you that range. Range can be minus infinity to infinity. So if my function is simply fx is equal to x, so x can take any value. And y will also take any value between minus infinity to infinity. Not always the range will be that. In this question, yes, it is between 0 and 1, both not included. Today, we take the next topic for practice, which is limit, continuity, and differentiation, derivative. For a single variable. For a single variable. Okay. We begin by talking about limits first. So first of all, limit means what? Limit means that we are going ahead and we are approaching a particular number. Does not mean we are finding the value at that number. So when I say that x approaches a, it means x is going very close to a. If I say x approaches 1, it means x is going very, very close to 1. So, x can take the value 0.999999, which is very close to 1, or x can take the value 1.00000001, something like this, which is also very close to 1. So when I say x approaches 1, it does not mean x is equal to 1. इसका मतलब ये नहीं है. What I mean here is that we are going towards 1 from both right and left hand side. Right and left hand side माने क्या? That if this is 1, we are going towards 1 by taking values very close to 1 from here. This is 0.9999999, which is close to 1 from this side. Or by taking values close to 1 from here, like 1.000000. We are going towards 1. Either from left or right does not matter. We are going towards 1. We are approaching 1. Now, in this, we have something which is called as the left hand limit. Left hand means from my left hand. I think it's a mirror image. It may seem right to you. From my left hand, I'm going towards that number, right? So we say like this. X approaches a minus. Mane, I am going towards 1, but from the left hand side. From the left hand side. So we are taking all values close enough to 1, but less than 1, right? So here we mean that x is less than. If we are approaching 1, but taking values less than 1, we can take the value 0.9999. We can take the value 0.99999. We can take the value. So it can be as close to 1 as possible, but less than 1. Then it is called as left hand limit. Whereas when we talk about the right hand limit, it means that we are going towards. I think there are some annotations here. Can you just see? Probably I see some blue lines in between. Ek bari dekh lena, huh? Okay. So when I talk about the right hand limit, right hand limit means that we are going ahead and we are approaching that number, but from the right hand side, right? So right hand side means we are taking all values, but which are greater than 1. Which are greater than 1. So इसमें हम क्या लेंगे? It is written as a plus, right? And we are going to take values like 1.001, 1.00001, 1.0000001, जो भी है, माने it has to be close to 1, but it has to be more than 1. Now, when does limit of a function exist? So that's the rule number 1 that we have. So a limit exists if one of these, what I'm writing is satisfied. What? So limit fx, when I go towards a from left hand side, is equal to when I go from a from right hand side, is equal to value of the function at a, right? And abhi, you don't have to write this also. We'll talk about this in continuity. Abhi ke liye we are just talking about limit. So a limit of a function exists. When will limit of a function exist? Limit of a function will exist when the left hand side will be equal to the right hand side. Then we can go ahead and we can say that yes, in fact, the limit of the function is existing. So this is called as existence of limit, right? This is the first thing which you have to remember. अब कुछ बुक्स क्या लिखते हैं ना, they represent this limit in a very different way. और वो इसको कैसे लिख देते हैं? वो लिखते हैं, and up to you, if you want, if you are clear with this definition, it's fine. But they say that, I'm writing the formal definition, the number L is the limit of the function fx as x, I am just writing जो भी ऊपर लिखा है in words, approaches a, written as limit x approaches a, fx equal to L, if, okay, I'll write everything in words only, for every number epsilon greater than 0, there exists, I'll explain this, a number delta greater than 0 such that if x minus epsilon, or you can just use some word a also, x minus a is less than delta, then fx minus L is less than epsilon. This is the official definition of limit. अब बहुत आसान है, क्या बोल रहा है? Let's understand. It says, so x minus a less than epsilon, ध्यान से समझना, x minus a less than epsilon में epsilon is a very small number, very very small number. x minus a less than epsilon, तो suppose मैं बोलती हूँ आपको कि a is 1. Suppose if I tell you x is 1.000001, तो बेटा what will be x minus a? x minus a हो जाएगा 0.00000001, एंड ये जो नंबर आया है इट शुड बी लेस देन डेल्टा, माने डेल्टा बहुत छोटा नंबर रहा होगा कि ये जो नंबर आया है इट इज द डेल्टा हैज टू बी इवन, आई मीन ये नंबर जो होगा इट हैज टू बी वेरी स्मॉल, क्योंकि डेल्टा जो है इट इज अ स्मॉल नंबर इटसेल्फ, and I want this gap between x minus a to be less than delta. तो in other words, ये वाला जो पार्ट है, in very simple word, ये बोल रहा है that x is approaching a. माने x and a का जो gap है, it is very small. The gap between x and a is very small. हाउ स्मॉल? स्मॉलर देन सम डेल्टा, बहुत छोटा गैप है एक्स और ए में। माने वी आर सेइंग दैट एक्स इज अप्रोचिंग ए, वही तो हमने यहां लिखा है दैट एक्स इज अप्रोचिंग ए, राइट? नाउ एक्स माइनस ए को हमने एब्सोल्यूट वैल्यू में क्यों लिया है? बिकॉज इट इज वेरी मच पॉसिबल कि एक्स कुड हैव बीन 0.00, एक्स कुड हैव बीन 0.9999, तो x minus a would have been what in absolute value? 0.9999 minus 1, तो ये भी यही आता 0.0001 ऐसे करके, बिकॉज वी आर फाइंडिंग इन एब्सोल्यूट वैल्यू, तो इट वुड हैव बीन सम स्मॉल गैप। तो हम कह रहे हैं कि ओके, x कैन बी स्मॉलर देन दिस a या x कैन बी लार्जर देन दिस a, बट उनका गैप शुड बी वेरी स्मॉल। दैट इज एग्जैक्टली व्हाट दिस इज, दैट x कैन अप्रोच a फ्रॉम लेफ्ट हैंड साइड या x कैन अप्रोच a फ्रॉम राइट हैंड साइड। माना वी आर गोइंग टूवर्ड्स दैट नंबर a, ठीक है? x जो है, x is going towards a, so if my a is 1, then x is very close to a, the gap between x and a is very very small. Then it says that the gap between function and limit should be very very small. माने जो वैल्यू आई एम गेटिंग, द फंक्शन दैट आई एम गेटिंग एंड द लिमिट दैट आई एम गेटिंग, दैट गैप शुड बी वेरी वेरी स्मॉल. If that happens, then we can go ahead and say that the limit of the function exists. So we can go ahead and show this graphically like this. So let's say I have a graph. This is my function. Okay, let's say I take a. And let's say मैंने यहां पे I am approaching a from both the sides. अब of course यहां पे I may have the value of the function. जब मैं a डाल रही हूं तो मेरे पास फंक्शन का कोई वैल्यू आ रहा है. Now what we are saying is that when I approach this a, चाहे लेफ्ट साइड से या राइट हैंड साइड से, so whether I take a minus delta, माने x का वैल्यू जो है वो a से बहुत पास है बट a से थोड़ा कम है, और whether I take a plus delta, a का बहुत पास है बट इट्स अ बिट मोर देन a, तो यहां से जो वैल्यूज आई गेट फंक्शन का, दे शुड बी वेरी क्लोज टू दिस, राइट? तो यहां पे दिस शुड जस्ट बी f of a plus whatever epsilon we had taken, and this should be f of a minus epsilon. This is what the definition of limit is. माने जैसे जैसे हम a की तरफ आए from both the side, as we come towards a, जैसे जैसे हम a की तरफ आ रहे हैं वैसे वैसे हम फंक्शन की वैल्यू की तरफ जाते जाए. This is what the simple definition is. As you go from, as you go towards a from both the side, you go towards the value of the function from both the side. If that happens, then that is the limit of the function. Now, there are some properties that you must remember from exam point of view. तो वो properties क्या हैं? First of all, the property can be related to the addition and subtraction. So if I have a function fx and I have a function gx and I am finding their limit, then I can apply limit separately, limit fx and limit gx, right? Similarly, if I have a function fx into gx and I have to apply limit on their product, so I can apply limit separately on fx and gx. Similarly, if I have quotient rational form में and I have to apply limit on this, then I can apply limit on this and this separately. But just remember, क्योंकि ये rational form है, the denominator cannot be equal to 0. So limit gx cannot be equal to 0. ठीक है? And subtraction में भी, I'll just write here itself. तो subtraction में भी it's true. ठीक है? So these are some standard limit laws that we have. Another thing which you have to remember, which is the L'Hopital rule. Then I'll give you some questions. L'Hopital rule says that there are some indeterminate forms. माने you can have a form of 0 by 0, right? Infinity by infinity, 0 into infinity, infinity minus infinity, 0 to the power 0, infinity to the power 0, 1 to the power infinity. Whenever you have indeterminate form, जब भी आपके पास indeterminate form आए, usually there are three things which can be done. और हम उन तीनों पे ही numerical करेंगे. So you can apply algebraic simplification. You can apply rationalization, and you can apply L'Hopital rule, in which we can talk about L'Hopital rule, but only after you study differentiation it makes sense. So in which we differentiate the numerator and denominator separately. I'll talk about this. How it works, we'll talk about that. Okay. So this is the three things which can be done. Now, एग्जाम पॉइंट ऑफ व्यू से बेटा कुछ स्टैंडर्ड लिमिट्स हैं जो आपको पता होना चाहिए. Some standard limits all of you should be aware about. ठीक है. The first standard limit which you have is sin x by x. माने एग्जाम में इतना टाइम नहीं है कि आप इसको डिराइव करने बैठो. So sin x by x, x tends to 0 is 1. Then x tends to 0, 1 minus cos x by x square is half. Then limit x tends to 0, 1 plus x to the power 1 by x is e. Then this is c, sorry, huh? Right. Then ln 1 plus x by x, limit x tends to 0 is 1. And limit x tends to 0, a to the power x minus 1 by x. This is ln e. Yes, this is ln a. So I'm quickly applying the L'Hopital. You should be aware कि इसमें फटफट अपने mind में you should be able to apply L'Hopital and get the answer. So this will be ln a. These are some standard limits which you can remember. I mean, जितना you practice, बहुत सारे questions में you'll see कि the questions can be quickly solved because you would know some of the limits on your own. Okay, so let's take the first question for the day. All of you try to solve this one. So question, limit x tends to 0, 1 plus 2x under root minus 1 minus 3x under root upon x, right? And the options are 3 by 2, 0, 5 by 2, 1. Give it a try. Okay, how about others? अच्छा, I have to give you one more question, ठीक है? Based on squeeze theorem, वो भी एक बारी करेंगे. So the moment we see these kind of questions, what we can do is पहले हम 0 directly apply करके देखते हैं. So we notice 1 plus 2 into 0 minus 1 minus 3 into 0 by 0. It's a 0 by 0 form. So I can either apply L'Hopital here or I can apply rationalization. Okay. Let's follow rationalization first. So rationalization में हम क्या करते हैं that if you see a negative sign here, you will multiply numerator and denominator with a positive sign. तो कैसे करेंगे हम इसको? We'll say 1 plus 2x under root minus 1 minus 3x under root upon x into 1 plus 2x under root plus 1 minus 3x under root upon x. Okay. So this is going to go ahead and give me, so we use the property that a minus b into a plus b is a square minus b square. So we get 1 plus 2x under root whole square minus 1 minus 3x under root whole square upon, sorry, my bad, why I have written x here. This will be 1 plus 2x under root plus 1 minus 3x under root. Okay, so my denominator will be x 1 plus 2x under root plus 1 minus 3x under root. And x tends to 0. So I'll get 1 plus 2x minus 1 minus 3x upon x 1 plus 2x plus 1 minus 3x. Limit x tends to 0. So 1 and 1 will cancel out. 2x plus 3x will be 5x upon x 1 plus this plus 1 minus this. X and x will cancel out. Limit x tends to 0. Now just put the value of x. So 5 upon 1 plus 2 into 0 plus 1 minus 3 into 0. So this is going to be 5 upon root 1 plus root 1, 1 plus 1, which is 2. So answer will be, where did the options go? C, 5 by 2. अब या तो आप rationalization से कर लो, or you go ahead and you solve by the other method, right? Which is your L'Hopital rule. I am fine with both. Okay, now question number 2, beta. Any doubt in this one? Anyone? Take it. Next question. So you have to tell me limit x tends to 0, x square sine 1 by x is a1, b0, c minus 1, d1 by 2. By L'Hopital use, yes. So you just differentiate numerator and denominator separately. So if I differentiate the numerator, what will I get? I'll get 1 upon 1 plus 2x under root, right? So just keep using the chain rule, right? So remember that when I am writing 1 plus 2x under root, that means it's 1 plus 2x to the power half, right? So power will come down, power will reduce by 1 into, remember that you have to also differentiate what is coming inside. So into 2, right? Similarly, if I differentiate this, this will be 1 by 2, 1 minus 3x under root. Into, you always differentiate whatever comes inside. So if this becomes difficult, please write this part as this. This will always make things simpler for you. So power comes down, power reduces by 1 into minus 3. You have to differentiate what is coming inside upon differentiation of the denominator. Don't apply quotient rule. you have to differentiate numerator and denominator separately for L'Hopital rule. Limit extends to 0. Now just plug in the value half. 1 plus 2 into 0 is 0 to the power minus half into 2. And this will be plus 3 by 2 because this is minus and minus. And this will be 1 minus 3 into 0 to the power minus half. Right? So this is just going to be 1. This is 1 plus 0 is 1 to the power anything is 1. This 2 and 2 will cancel out. So this will be just 1 plus 3 by 2. This is just 1. So this will be 1 plus 3 by 2, 5 by 2. Okay. Is it clear now? Okay. So now let's talk about the second question. Again, there are multiple ways to solve this question also. I mean, it depends on how you want to solve it. So first of all, I will solve this using squeeze theorem. Listen to me very carefully what squeeze theorem says. Squeeze theorem says that if whatever I have, whatever function is given to me, it is bounded between two functions. And when I apply limit on these functions, I get the same answer. फिर से बोलूंगी. I have a function fx. Fx is between gx and hx. And when I apply limit to gx and limit to hx, I get the same answer. जो भी answer आ रहा है, you can get some delta. जो भी, you're getting the same answer. Then even for this function, the answer is that delta only. That is called as squeeze theorem. Let's try to see if that works here. So whenever we talk about the function sin x, whatever be the angle here does not matter. But when I talk about the function sine always is bounded upper and lower by 1 and minus 1. So when I would write sine 1 by x, this will always be between minus 1 and 1. Now, this is this part. But what is the function given to me? The function given to me is x square into sine 1 by x. Man, I need to multiply it by x square, na? So I will multiply x square on all sides. And I'll get minus x square less than equal to x square sine 1 by x less than equal to x square. I will check the limit of these two, the extreme functions. So when I check limit x tends to 0 minus x square, you put 0 in this and you get 0. And when you check limit x tends to 0 x square, you get 0. So the functions this and this, as x tends to 0, this also goes towards 0 and this also goes towards 0. They're going towards the same number. So it means that ये जो function है, ये जो gx है, it's approaching 0. And ये hx भी is approaching 0, जो extreme sides हैं. So the function in between, जिनके बीच में it is squeezed, must also approach 0. So therefore we can say that this x square sine 1 by x will also approach 0. All of you are right if you have said that the answer will be B. But you can definitely do this question by L'Hopital. Right? There is nothing wrong in it. Mane, you could have written this function as this sine 1 by x, or ये x square को I can write 1 by x square. Right? I can write this as 1 by x square. So then also it is fine. And I can apply L'Hopital on it. So up to you how you want to do it. But yes, you're right that the answer will be 0. Okay. Now, so I'll give you an economics oriented question. Right? That's also fine. You can apply that. That's right. Okay. So consider constant elasticity of substitution production function with x and y as inputs. Then as rho tends to 0, limit rho tends to 0, x to the power rho plus y to the power rho upon 2 to the power 1 by rho approaches, right? A xy, b root xy, c 1 by xy, d 0. Give it a try. Yes. So you can just differentiate numerator and denominator separately. Differentiation of sine is cos. Differentiation of 1 by x is minus 1 by x square upon 1 by x square. This will cancel out. This will give you minus cos 1 by x, right? And you can just go ahead and apply it. Oh, sorry, I didn't differentiate the denominator yet. So you can differentiate the denominator separately. So this will be x to the power minus 2. So when I differentiate it, it will be minus 2 x to the power minus 3. So this will be cos 1 by x into minus 1 by x square upon minus 2 into 1 by x to the power 3. Right? So this will go ahead and cancel itself. Right? And you will go ahead and you will get cos 1 by x upon 1 by x into 1 by 2. Okay. And you can just apply limit x tends to 0 on this one. Okay, how about others? How are you solving this? Sorry, this is the question. I'm just thinking there can be one more way in which we can solve this. I mean, as I said, there are many ways, but you could have done, I don't know if some of you tried it. This can be x into x sine 1 by x, right? And you can apply this property as well, right? So just think about it. So whatever my angle is here, if I have sine x by x, if this is 1, limit x tends to 0, this is very well equivalent to sine 1 by x by 1 by x, limit x tends to 0 equal to 1. Mane, the point is that whatever angle comes here should come here. Whatever angle comes here should come here, right? So you could have very well used that property also. So you could have done this as x sine 1 by x by 1 by x. And then you could have said that since we are applying limit on product, it is limit of individual numbers. So limit x tends to 0 into x and limit x tends to 0 sine 1 by x into 1 by x. Just apply limit individually and get the answer. So again, there are many ways, up to you how you want to solve, but you would see that this example usually comes in the squeeze theorem example. Okay. Okay, just try this one. This is a very interesting question, but if I start solving it, it is a 25-30 minute analysis. You may not have that much time in exam. You have to remember certain things from the point of view of exam. कुछ चीजों को याद रखना बहुत जरूरी है. So, yes, for people who have taken log, you are moving in the right direction. माने अगर आपने ऐसे किया है, y is equal to x to the power delta plus y to the power delta by 2 whole to the power 1 by delta, and you have taken ln on both sides. You are moving in the right direction, but it is going to be a very hectic analysis, right? So just remember these kind of questions. कुछ चीजें आपको याद रखोगे तो ज्यादा आसान रहेगा एग्जाम में. That when we have this kind of constant elasticity of substitution function, it approaches its geometric mean. It approaches its geometric mean. Of course, you can go ahead and solve it. You can take ln m to the power n. 1 by rho can come here. It can be ln x to the power rho plus y to the power rho by 2. Of course, you can take limit. But जब आप limit लोगे, so you will see that here you will get 0. Right? And you will notice that here also, ये जो पूरा चीज बनेगा, this will become 0. Right? And this will also be 0. So it will be a 0 by 0 form. So you will apply L'Hopital and solve. I am leaving it to you if you want to try. So you will apply L'Hopital. L'Hopital करके you will solve this question. ठीक है? And then जो भी यहाँ पे आंसर आएगा, that will be ln y. तो y निकालने के लिए you will take it to the exponential power. So y will be e to the power whatever answer you get here. but पूरा solve करोगे, you will notice that the answer is actually coming out to be geometric mean. So it's a property. And just remembering this property will be a good thing to be done. Continuity. Now, a function, first I will give you the definition. A function fx is called continuous function. In general terms, it's called continuous function if there is no jump, if there is no break, right? Then we go ahead and we call a function a continuous function. No jump, no break. You pick up a pen and you continue drawing. You don't have to pick up your pen back. These are the informal definitions of continuity. But formally, a function is called continuous at point A if first f of A is defined. Second, left hand limit is equal to right hand limit is equal to the value of the function. That means limit x tends to A, f of x is equal to f of A. If this is satisfied, then we can go ahead and we can say that the function is continuous. A continuous means sometimes in exam, they may go ahead and they may ask you left hand and right hand continuity. Left hand and right hand continuity. So left hand, a function may be left hand continuous. सिर्फ लेफ्ट हैंड से कंटिन्यूअस होगा if limit x tends to a minus fx is equal to f of a. And a function is right hand continuous if limit x tends to a plus fx is equal to f of a. Okay. This is called as one side or one hand continuity. Then we have the types of discontinuities. The types of discontinuities, in which the first one we have is called as removable discontinuity. Okay. Removable discontinuity is any discontinuity which can be fixed. If any discontinuity can be fixed, then it is called as removable discontinuity. Jaise, example, f of x is equal to x square minus a square upon x minus a. Now, you will notice that the function is not defined at a. Because the moment I will put a in the function, I will get a 0 by 0 form. Right? The function is not defined at a. But I can go ahead. Okay. Let me know it's once it's done, huh? But I can go ahead and I can remove it. How? So I can go ahead and I can write ye x minus a, x square minus a square as x minus a into x plus a upon x minus a, and this will cancel out and I will get x plus a. So now when I find the value of the function at a, I just get the answer as 2a. So we could fix it by redefining the function. My original function is this, but I fixed it by writing it as this, right? This is called as removable discontinuity. The second one that we have, that's called as jump discontinuity. Jump discontinuity just goes ahead and says, okay, this one. Okay. Jump discontinuity just goes ahead and says that we are taking a jump. Mane, limit x tends to a minus. When I approach the number from left hand side, I get L1. And when I approach the number from right hand side, I get L2. And L1 is not equal to L2. Right? It's a typical step function that you go ahead and get. Right? In economics, when we do price ceiling, price floor, तो ये एक typical step function होता है कि एक point तक एक level पे और एक income के बाद दूसरे level पे जब tax charge होता है. So these are all discontinuities at A, right? So if I have to plot this, if I take this A, up to A there is some value, and after A there is another value. So there is a jump discontinuity that has taken place. Now, the third one that we may have, they are infinite discontinuity. Infinite discontinuity means that as your x goes towards A, fx may go towards plus minus infinity. Okay. So once it may go towards plus infinity, the other time it may go towards minus infinity. That means you may have vertical asymptotes, right? Just say ऐसा कुछ. When we are going towards 0 from left hand side, it is going towards, the function is going towards plus infinity. And when we are going towards 0 from the right hand side, then my graph looks like this. It is going towards minus infinity. Right? So I'm going towards plus and minus infinity. I am approaching 0 from both sides. Right? So there is a vertical asymptote. Q asymptote because you are going towards infinity. You're approaching infinities. So it's a vertical asymptote. Right? But it's a discontinuity. Right? Then you may have something which is known as oscillatory discontinuity. Oscillatory. This is OSCI. Oscillatory discontinuity. Oscillatory discontinuity is when the function is oscillating between two values. Mane, it goes towards -1, then 1, then 1, then -1. Right. So it is between two values only. But we cannot tell which value it will approach. The limit does not exist because we don't know कौन सा value की तरफ वो जाएगा. So these are basically your oscillatory discontinuities that you have. Now we'll take some questions to understand all these topics well. तो पहला question लेते हैं. You have a function. The function, you should never draw these brackets like this. Always draw like this, huh? I have a habit of drawing double bracket. Ax square plus bx plus 1 for x less than equal to 1. This is a very famous question, especially when it was a JNU paper. These kind of questions were very popular. X square minus 4 for x greater than equal to 3. Find A, B, and C such that function is continuous on R. Give it a try. Okay, we actually covered most of the questions, PYQ questions of GATE and IIT when I was taking the live classes of the main integrated batch, right? Now, the idea is that it's spread across different lectures. So I have asked team to crop those and put it in one place. So I think we should get them by the end of next week. Most of them we have solved in class, but just that they are spread across lectures. We have to go ahead and we have to crop and put them in one place. For CUET, I have to do the paper of 2025, but I'm waiting for these semester exams to get over because I'm not seeing a lot of attendance in these classes and I need people for PYQs. So एक बारी exam हो जाए semester का, we'll do that in one of the weekends. We'll take them in class. Oscillatory discontinuity. Huh. So it just means that you are oscillating between two values. You're not reaching one of the values. Just if I ask you that limit x tends to infinity, what happens to sine x? You cannot tell because sine x looks like this. It oscillates between 1 and -1. But as you approach infinity, जैसे आप infinity की तरफ जाते हो, are you approaching 1 or are you approaching -1 is not very clear. ये नहीं पता हमें कि 1 पे हम approach करें -1 पे. So we really cannot go ahead and tell that. That's why it is oscillatory in nature. Okay, give this question a try, all of you. So what about other universities? When are your semester exam getting over? Anyone whose exam is extending till Jan? Because this is really disturbing the entire entrance flow. Yes, by 30th, right? By second Jan is fine. I hope that now we can give the entire 17 December excellent. We can give the entire Jan and I mean Feb mein to we rarely have time. But at least you should be giving the entire Jan dedicatedly for your IIT and GATE if you want to appear. जो भी लोग appear हो रहे हैं IIT या GATE में, you should be dedicatedly just giving the entire Jan to that. Stop going to college, please, and give 100% of your time to this preparation. International, not a lot of time. Just know some basic thing. You should know what is a J curve, what is Mundell-Fleming model. You should know what is, for example, the equation of the J curve. Huh? Like what's the Marshall condition there? ठीक है? Then Dornbusch overshooting model. मॉडल्स में अगर इंटरनेशनल में पढ़ना है देन यू शुड नो रिकार्डियन एंड हिग्जर-रोलैंड, ये दो बहुत बेसिक मॉडल्स हैं. तो कुछ चीजें हैं विच वी नो विल कम इन एग्जाम, यू कैन नॉट स्किप दोस. आई मीन इफ यू सिट फॉर 3-4 days, उससे ऊपर इंटरनेशनल में कुछ है नहीं विच विल बी आस्क्ड इन एग्जाम. एंड एनीवेज इट विल हेल्प यू इन योर 6th semester, especially in Delhi University. International comes in 6th sem. Is it in Jan or Feb? I don't know, but my suggestion is that you go ahead and you simultaneously pick up on the entrance preparation. It will become very difficult अगर हमने Jan Feb में भी नहीं किया तो. This only, make a note. No, I just told you यही है बस international में important. Okay, what's the answer we are getting? So for continuity, we require that left hand limit should be equal to right hand limit should be equal to value of function. माने when I put x equal to 1 in this function, and when I put x equal to 1 in this function, I should get the same answer. So a 1 square plus b 1 plus 1 should give me 2 into 1 plus c. So a plus b plus 1 equal to 2 plus c. So a plus b minus c equal to 1. Similarly, continuity at 3 means that I should get the same answer from the function, left hand and right hand limit. So it means when I plug 3 in this and this, I should get the same answer, right? So I get 3 into 2, 6 plus c equal to 9 minus 4. Right? So you have got the value of c as minus 1. Now you can just go ahead and put c in the equation. So if I put c as minus 1, so you get a plus b equal to 0. That means a equal to minus b. So there are infinite values of a and b. b 4 होगा तो a minus 4 होगा, b 5 होगा तो a minus 5 होगा. So from here we get infinite values of a and b and c equal to minus 1. This is your answer. Is it clear? Very, very common question from exam point of view. बहुत common question है ये exam में आता है. That you have to go ahead and you have to tell what will be the values of parameters such that the function becomes continuous. So you put the function in this one and this, and it should give you the same value. Similarly, you put 3 here and 3 here, and it should give you the same value. Okay. Now, next question, beta. Conclusion. Conclusion is that since I get a plus b equal to 0, it means a is equal to minus b. So I've got an equation rather than getting 1 or 2 values of a and b, right? So I've got that, okay, b can be 1, a will be minus 1. B can be 2, a can be minus 2. Any a and b that satisfies this equation is fine to me, isn't it? So I have got that there are infinite values of a and b. And c can have only one value, which is minus 1. Is it clear? They can give you a question based on that. Okay, fine. So let's begin by talking about differentiation first. The first thing which can be asked in differentiation is going to be the formal definition based on the limit approach. Based on the limit approach, differentiation ka definition f dash a is limit. So what is f dash a? How the function is changing, right? Say suppose I want to ask how the function is changing when x is equal to a. When the function fx, in that function x is equal to a, mane I draw a function and here I take x is equal to a. This is different values of x. Now when x is a, then what is the, in a way, what is the slope of this function? How this function is changing, that is the derivative. So through the limit approach, agar hum limit approach ki baat kare, then f dash a is limit h tends to 0, f of a plus h minus f of a by h, right? This is also called as measuring the instantaneous change or instantaneous rate of change of a variable. Okay, so that's the first thing which we should know. Ki we are trying to go ahead and we are trying to ask how the function is changing, the rate of change of function divided by this h, right? Now, if the derivative of the function is greater than 0, we can say that the function is increasing. If the derivative of the function is less than 0, we can say that the function is decreasing. And if the derivative of the function is exactly 0, then we can say that at this point, the function can have maxima, minima, or point of inflection. So usually whenever we have to go ahead and we have to find maxima or minima, we will go ahead and we will we will find the differentiation. We'll do the derivative of the function and equate it to 0. इस case में we need to know the graphical implication also, which I already wrote here, that graphically the slope of the tangent at a point, right, that is basically the derivative of the function. हम क्या कर रहे हैं उसमें, हम उसमें जाकर उसका slope निकाल रहे हैं at any point. That is what we are trying to go ahead and do. फिर कुछ basic rules है हमारा differentiation का. I hope all of you know that. It's very basic that if I have x to the power n, its differentiation will be n x to the power n minus 1. If I have a constant, its differentiation will be 0. If I have constant multiplied to a function, its differentiation will be constant into derivative of the function. If I have sum of two functions, its derivative will be differentiation of first plus differentiation of second. If I have product of two functions, its derivative will be first function into second as it is plus second function into first as it is, derivative. If I have the quotient, right? So if I have fx by gx, as long as this gx is not equal to 0, then its derivative will be differentiation of first, second as it is, minus differentiation of second into first as it is upon second whole square, upon second whole square. Then the most important in economics is the chain rule. So if I have y as a function of gx, right? And I have to find how y changes as x changes. So f is a function of g. G is a function of x. So you will first differentiate with respect to f. The function f will be differentiated, and then the function g will be differentiated. And this is called as the chain rule. Then if I have an exponents, its derivative remains as it is. If I have a constant to the power x, right, then its derivative will be ax ln x, sorry, ln a. If I have ln x, then its derivative will be 1 by x. And if I have log x to the base a, ln means its base is e. But if I have log x with base a, then this will be 1 by x ln a, right? So these are some of the derivatives that you should know. Now, apart from this, you must know how to do concavity and convexity of function. So if the double derivative is negative, concave, double derivative is positive, convex, right? And then they may ask you about the Taylor approximation. So in Taylor approximation, fx is approximately equal to f of a plus f dash a x minus a if it is a linear approximation. And if it is a quadratic approximation, then you have fx is approximately equal to f of a plus f dash a x minus a plus f double dash a by 2 x minus a whole square. Right? So sometimes they may ask you about the Taylor approximation also in exam, and that is important. Okay. We have already seen a lot of differentiation while doing microeconomics. माने हमने marginal product और ये सब already निकाला है. So it's not a new thing. अच्छा, okay. Let me know once it's done, huh? That's also fine. I mean, you can know that approximation also, but Taylor is usually more asked in exam. Achha, okay. Let me know once it's done, huh? ठीक है. So let's do some questions now. So you're given fx is equal to x minus 3 mod plus x minus 1 whole square. Find value of x that minimizes the function. Give it a try. Take a minute. Try to do this yourself. Just open the absolute value window, huh? Okay. How about others? Hmm. Okay, let's try. So if x is greater than 3, function will be x minus 3 plus x minus 1 whole square. This will be x minus 3 plus x square plus 1 minus 2x, x square plus minus 2 minus x. Differentiate the function 2x minus 0 minus 1 equated to 0, x is half. Double differentiate the function, you get 2, which is positive, right? So we will go ahead and we will keep it here for now. Now let's go ahead and let's check what happens when x is less than 3. If x is less than 3, then my function, if I open this up, this becomes minus. We'll come to conclusions later. We just need to solve this mathematically first. Minus of x minus 3 plus x minus 1 whole square. So I go ahead and I get minus x plus 3 plus x square plus 1 minus 2x. I get x square minus 3x plus 4. I differentiate the function. I get 2x minus 3 equal to 0. X is equal to 3 by 2. I double differentiate the function. I get 2 greater than 0. So this also represents minima and this also represents minima. Now, look that here I had assumed that x should be greater than 3. X should be greater than 3. But the answer I am getting is x is equal to half. It's not greater than 3. So it is a negation. It is not correct. The answer I am getting is half. And I have assumed that x should be greater than 3. So ये गलत हो गया. Now if I look here x should be less than 3. And I am getting x as 1.5. This is fine. Now let's go ahead and evaluate what happens if x is exactly 3. If x is exactly 3, if I have this function, if I put x as exactly 3, then this will become 0. Right? I can directly find the value. मुझे कुछ करने का जरूरत नहीं है. And I will go ahead and I will get the value of the function as 0 plus 3 minus 1 whole square, 2 square, which means 4. So at x equal to 3, the value of the function is exactly 4. And what is the value of the function when x is 3 by 2 or 1.5? So value of function at 1.5 will be 1.5 minus 3. I'm putting it in this one, 1.5 minus 3 in absolute value plus 1.5 minus 1 whole square. That means it will be 1.5 plus 0.5 whole square, 1.5 plus 0.25. This will give you something as the answer. So you notice that here, yes, the least value in the three cases that we took, less than, greater than, and equal to is coming here, 1.75. So anyone who has answered it as 3 by 2 is correct. How did you get 2 by 3 here? And so many people, how are you getting 2 by 3? Is it clear now? Any doubt, anyone? Very basic question. We cannot afford to do wrong in such questions. Okay, write down the next one. A very commonly asked question. Evaluate. Limit x tends to 0, derivative of x square e to the power 1 by x. Do it. Everyone solve it. I'll give you some options. 0, ln x, e to the power x does not exist. Okay, good. All of you are right. So if I differentiate this, differentiation of first function, second as it is, and then you differentiate the second function and hold first as it is. Okay, so just do that. Differentiation of second function. Use chain rule. So differentiation of e to the power 1 by x is e to the power 1 by x into differentiation of 1 by x, which is minus 1 by x square, into first function as it is. Right? Now, this and this cancel out and you get 9. This one and this. Now, what's the question saying? The question is saying we need to go ahead and we need to evaluate the limit of this. Limit at as x tends to 0. Now, here is the interesting fact, right? So, you can only understand this fact if you know how to go ahead and how to plot the e to the power x function, right? So just think about exponential functions. How do you go ahead and how do you make these exponential functions? If I were to plot e to the power x, this would have been like this. This is e to the power x function, right? Can you tell me how e to the power 1 by x function will look? Anyone? Will it be a mirror image? Will it be downward sloping? How e to the power 1 by x will look? Did anyone try that? Okay. So for that, you just think about what happens when, to plot the function e to the power 1 by x, you just think about how this function will act at x equal to 0. So if I just go ahead and if I put 0, anything by 0 is infinity, isn't it? Now e to the power infinity should be infinity. So which means that here there is something fishy because I'm getting infinity, which means there might be some asymptote. I have to think about it. And how can I think about it? Well, try to go ahead and try to take two numbers. 1, 0, positive, but close enough to 0. Man, if I take 0.0000000000001. So I'm क्योंकि यहाँ पे infinity आया, I should be looking at the two sides of 0 कि 0 के right hand side पे क्या हो रहा है और left hand side पे क्या हो रहा है. So if I approach 0 from the right hand side, माने if I take a number which is positive but very very close to 0, तो यहाँ पर I will get e to the power 1 by 0.000000000. माने it is a positive number, राइट. तो एनीथिंग, जब हम एक नंबर को एक बहुत स्मॉल नंबर से डिवाइड करते हैं, दिस इज अ वेरी स्मॉल नंबर. So when we divide a number by a very small decimal number, we assume that it approaches infinity. वो बहुत बड़ा नंबर निकल के आएगा. 1 divided by 0.000000001, this will be a very big number, one with many zeros. जितने zeros यहाँ हैं उतना zeros होगा when you will divide this number by 1. So mane this will be very very big number, mane infinity. So this will be going towards infinity. E to the power infinity is infinity. But if I take any number close enough to 0 but less than 0, mane if I take a negative number, जैसे if I take 0.0999999, say 0.00000000001 with a negative sign, suppose. That means very close to 0. 0 के पास ही है, but it's a negative number. So when I will do 1 by minus of this, तो ये एक negative number देगा, isn't it? So this will give me e to the power minus of this number, minus of whatever this number is. And whenever the power is negative, you take things and reciprocate them. So this will be nothing but 1 by e to the power 1 by this. And ये तो infinity है. So it will be 1 by infinity. माने this will approach, anything by infinity is 0. This will approach 0. So this is very interesting question. When I try and I approach this function from the left hand side, क्योंकि negative power है तो वो denominator में चला जाएगा, तो वो 0 की तरफ जाएगा. The function will approach 0. But when I approach this function from the right hand side, the function will approach infinity. The function, when I approach 0, it will go towards infinity. And when I go ahead and when I approach it from here, it will go towards 0. Right? So this means that this y-axis, this will act as a vertical asymptote of this function. And this also means that the limit does not exist. क्योंकि when I say limit x tends to 0 plus e to the power 1 by x, I get infinity. But when I say limit x tends to 0 minus e to the power 1 by x, I get 0. Now holding this important information, homework for all of you. I will not do it in class. I have given you enough hint. Homework, plot e to the power 1 by x. It's a homework for all of you to plot this. ठीक है? Okay. Yes. Do you want to understand this again? Is this a doubt or you only how it is 0? See. I have e to the power 1 by x, but x is a negative number. So if I tell you, because it's close enough to 0 but less than 0. So if I tell you, how do you write x to the power minus 2? You will tell me, ma'am, this is nothing but 1 by x to the power 2. How do you write e to the power minus x? Ma'am, it is nothing but it is 1 by e to the power x. So when you have negative power, it goes in the denominator. You reciprocate it. That is exactly what is happening here. Since I am taking a number close enough to 0 but less than 0, mane I am taking a negative number. So if I am taking a negative number, to make that positive, I can say it will be 1 by e to the power 1 by x. Now you can take x as its absolute value, a positive value. See, minus 2 became 2. Minus x became x. So now this is 1 upon e to the power 1 by x. And I know that e to the power 1 by x, we proved that this is approaching infinity. We did that, right? So it is actually 1 by infinity, which means anything by infinity is 0. So it goes towards 0. Is it making sense now? Please ask if there is any doubt. It's a very commonly asked question, variable optimization. So optimization means what? Optimization means that we want to either find maxima or find minima of the function. And when we want to find maxima or minima of the function, there are two things which we want to go ahead and do. First, we want to find out something called as first order condition. I am doing one variable first. And then I'll talk specifically about two variable and what Bayesian matrix is, probably today or tomorrow. Let's see how we go. So we're talking about first order condition. पहले हम इस first order condition के बारे में बात कर लेते हैं. In which we either, when we want to maximize or minimize, we differentiate the function and equate it to 0. This is called my first order condition. Okay. Now, because I am differentiating the function and equating it to 0, first order condition में, it automatically goes ahead and means ये सिर्फ तब possible होगा अगर मेरा function differentiable होगा. Otherwise, it's not possible. So, माने in the background, my function must be differentiable. अच्छा, और differentiable के लिए minimum चीज क्या चाहिए था? अगर differentiable है, it must be that the function definitely is continuous. It must be that the function definitely has existence of limit. तो ये सब रहा होगा. Limit must have existed, function must have been continuous, function must have been differentiable. That is why I'm able to differentiate the function and equate it to 0. That's the reason why with substitute codes, why with complementary codes, why with max utility function, उसमें हम first order condition नहीं निकालते. ये हम first order condition सिर्फ Cobb-Douglas में निकालते हैं. Why? Because we understand that we have to have a continuous indifference curve which is also differentiable. अब जब हम अपना complementary goods का बात करते हैं, it's a min function, इसमें kink आ जाता है. They are not differentiable. When we talk about max functions, these are not differentiable. So basically, the first order condition requires, क्योंकि मैं differentiate करके equate to 0 कर रही हूँ, so it requires that the function must be differentiable. Secondly, ये तो first चीज हो गया. Secondly, I require that the second order derivative can be, it can have different things. It can be less than 0, equal to 0, or more than 0. Now, if it is less than 0, you achieve a maximum of the function. If it is more than 0, you achieve a minimum of the function. And if it is equal to 0, then it's inconclusive. मैक्सिमा और मिनिमा के बारे में हम बात नहीं कर सकते. So here, because I am checking the second order condition, मैं double differentiate कर रही हूँ, so it means that the second order derivative should exist. So that's the second thing which I require, that the function should be not only once differentiable but twice differentiable. सिर्फ एक बारी नहीं, function दो बारी differentiable होना चाहिए. The function should be differentiable twice, right? So this is the first thing which we require कि maxima, minima ये सब तो बात का बात है, right? But basically we need that the function should be twice differentiable. ठीक? Then there are some terms which you must know. So one such thing which can be asked in exam is called as an inflection point, right? And one another thing which can be asked in exam, that's called as a stationary point. अच्छा, before we proceed, ये बात समझना that whenever you have maxima of the function, that is, you can resonate that with concavity. Double order derivative negative माने concavity. And double order derivative positive माने convexity. ठीक है? Now there is something called as an inflection point and something called as a stationary point. जब हम stationary point के बारे में बात करते हैं, when we talk about stationary point, then we can say x dot or x naught is a stationary point if when I find the first order derivative of the function at that point, I get 0. So if it happens कि जब हमने first order derivative निकाला and वो 0 आ जाए, right? Then it is a stationary point. अब whether it will be maxima, minima or nothing does not matter. अभी के लिए सिर्फ इतना मैटर कर रहा है that a stationary point is any point such that the first order derivative is equal to 0. ठीक है? Now there is something which is known as an inflection point. Inflection point usually, और ये आपको दिखता है when we talk about the cost functions, right? जब हम total cost function के बारे में बात करते हैं, that is where we go ahead and we look at an inflection point. अच्छा, एक और चीज है, before I move, we can just write here saddle point. Right? अब हम बात करते हैं inflection point का. So inflection point is any point where your curve changes the curvature. ठीक है? Where the curvature of the function changes. Where curvature of the function changes. माने, so if you draw cost curve, you will notice that the curvature of the function is changing, right? But when we draw the revenue curve, total revenue curve of a monopoly, the curvature of the function is changing. So whether you go from concave to convex or convex to concave, in between that point where you're changing the curvature, right? That is basically called your inflection point, right? Change in curvature is called as your inflection point, right? So we can say, some books say that the concavity of the function changes at x naught, then that is an inflection point. Okay. Now, We also have something which is called as a saddle point. So what is a saddle point? A saddle point is that stationary point in a multivariate function that is neither maxima nor minima. माने फर्स्ट ऑर्डर डेरिवेटिव तो इक्वल टू जीरो आया है, but it is neither local maxima nor local minima. So a stationary point neither local maxima nor local minima. If that happens, then that becomes your saddle point. ये दो तीन कुछ definitions हैं. They can be asked to find. हम एक एक क्वेश्चन करेंगे how to find them. But you can also be asked as point of match the following or as point of MCQ. कैसे भी आ सकता है. So it is important that you also remember the definitions of these questions well. ठीक है. Now, so as I said, we will go ahead and we will begin by talking about the single variable function, and then we will move on to the multivariable function. So write down the first question. Maximize fx is equal to x to the power 4 minus 4x to the power 3 on R naught. Do it. A, it is maximum at x equal to 3. B, at x equal to 0. C, no maxima. D, at x equal to positive infinite. Okay, how about others? Yes, you have a query? ठीक है, तो देख लेते हैं. So f dash x is equal to 4x cube minus 12x square equated to 0. Minus 12x square equal to 0 means I can take this here. अच्छा, एक चीज है यहाँ पे. हाँ, this many of you make a mistake. You simply cancel x's. मतलब what you will do is, ये बहुत गलत है, that if you will write this as 12x square, you just cancel x's and make x here and x equal to 3. Wrong. Very incorrect. It is not this. If I would have taken x square common, I would have got 4x minus 12 equal to 0. The product of two things is 0. दो चीजों को मल्टीप्लाई करके 0 कब आता है? when one of them is zero, दोनों में से कोई एक जीरो होना चाहिए. So it means either x square is zero or x is equal to 3. Both of them are fine. You have to check at both. सिर्फ x equal to 3 पे चेक नहीं करना है. It will be incorrect. X can also take the value 0. Very basic, but I hope all of you know this, but I'm just reiterating. Up double order derivative. This is my first order derivative. So 4 into 3, 12x square minus 24x. Now check at 3 and 0. So 0 I get 0 and 3 into 3, 9 into 12, 108 minus 24 into 3. Positive. So this is minima and this is inconclusive. So all of you are right. Acha, now this is fine. But can you tell me exactly why there is no maxima? माने ग्राफ में क्या ऐसा रहा होगा कि there is no maxima? Why there is no maxima? कोई अगर पूछे कि इसमें मैक्सिमा क्यों नहीं आ रहा, why no maxima? Horizontal graph, okay. Anyone else? Why ऐसा क्यों हो रहा है? इस फंक्शन में मैक्सिमा क्यों नहीं है? Write down. The function doesn't have any maxima because it is unbounded. Because it is unbounded. माने what we are saying is कि देखो यहां पर x to the power 4 है और ये x to the power 3 into 4 है. So for large x's, जैसे जैसे हम x का ज्यादा ज्यादा वैल्यू लेंगे, for large x's, clearly x to the power 4 will exceed 4x cube. माने just take an example. सपोज मेरा x जो है वो 10 है. सपोज क्लियरली 10 to the power 4 ये हो गया बेटा 10000 एंड 4x क्यूब हो गया 4 into 10 to the power 3 4 into 1000 माने 4000. अभी तो मैंने कुछ x लिया ही नहीं है. आई हैव टेकन अ वेरी स्मॉल x. अभी तो मैंने x को सिर्फ 10 लिया है और मेरा इसका जो आंसर आएगा इट विल बी 10,000 माइनस 4,000 6,000. बट एज आई इंक्रीज x, जैसे जैसे मैं ये x बढ़ाती जाऊंगी, when I increase this x to 100, when I increase this x to 1000, तो इनके बीच का गैप विल कंटिन्यूअसली इंक्रीज x to the power 4 and 4x क्यूब का. माने इस फंक्शन का वॉट एवर वैल्यू आई विल बी गेटिंग इट विल बी बिगर एंड बिगर एंड बिगर. एंड व्हेन x विल गो टूवर्ड्स इंफिनिटी तो ये फंक्शन का वैल्यू भी इनफाइनाइट होगा. बहुत बड़ा गैप होगा. द आंसर ऑफ दिस विल बी वेरी ह्यूज बट वी डोंट नो व्हाट दैट नंबर इज. सो सिंस दिस फंक्शन इज अनबाउंडेड माने जब हम इसमें अलग अलग x डालते हैं द वैल्यू इज कंटिन्यूअसली इंक्रीजिंग बट देयर इज नो बाउंड. कोई अपर लिमिट नहीं है. तो देयरफॉर देयर इज नो मैक्सिमम. देयर इज नो बाउंडेडनेस ऑन दिस फंक्शन. Now tell me something. If I make this function bounded, mane suppose they would have gone ahead and said कि this is your function defined for all x between -4 to 4. तो अब I have an upper bound कि x 4 से ऊपर नहीं जा सकता. X cannot take the value more than 4. So then I can check at those extremes कि उन extreme points पे क्या हो रहा है. But here since the function is unbounded, जैसे जैसे x बढ़ाए जा रहे हो function का value बढ़ता जा रहा है. Right? So no maxima for the function. Is it clear? No, it cannot be D. That's the beauty. The value of the function should be some number. If I don't have a number, I cannot say maximize infinity. That's no answer. So you need some number for it. That is why this is incorrect. Okay. Okay. So next question. If we are not able to find a minima, then what is the case? Then no maxima, no minima. That's okay. It may happen कि the function is suppose this is my function. Suppose I say, और simple सा example लेते हैं. Let's say my function fx is simply x. And I tell x is defined for all real values. माने I don't give you a limit. So fx equal to x is just a 45-degree line like this. Now for this there is no maximum value, no minimum value. Neither exists. कुछ भी exist नहीं करता. जैसे जैसे x बढ़ता जाएगा वैल्यू बढ़ता जाएगा, जैसे जैसे x कम होता जाएगा वैल्यू कम होता जाएगा. But I cannot tell you what's the highest value or what's the lowest value. If minima does not exist, it does not exist. Maxima does not exist, it does not exist. Is it clear? Okay. So now I'll give you an interval based question. So let's say your function is x minus 2 whole square plus 1 upon x plus 1, and x is defined over 0 to 4. Then the minimum, you have to tell me the minimum value of the function. Hello everyone. Hanji, so what will be the answer? Solve this. व्हाट आंसर आर वी गेटिंग? क्या मिल रहा है यहाँ पे आंसर आगे? कौन सा एक्स है जो सॉल्व करेगा इसको? ऑल ऑफ यू नो हाउ टू सॉल्व क्यूबिक फंक्शंस? यस, नो? ठीक है, सो गो अहेड, टेल मी. Which x will solve this? Factorize it. Karo factorize. Give me the values of x. Okay. Okay. Whatever answer you're getting, if it's root 2, then root 2. Because I haven't solved it further. So I'll give you the steps. Number 1, you factorize this. You get some x's, right? Number 2, you check the value of the function. At x equal to 0 and x equal to 4, extreme. And add these x's. Right? Wherever it is minimum, that's your answer. Right? So that is how you can go ahead and you can solve this question. I think I should have created a bit easier one, जहाँ पे factorization थोड़ा आसान होता. But usually you'll be given factorization which will not be very, very difficult. Right? माने यहाँ पे you will have to think about which x really goes ahead and solves this equation. But otherwise it is usually not that difficult. बहुत easily identify हो पाता है कि x equal to 1 solves or x equal to 2 solves. Right? If there is still any doubt, you go ahead and you let me know in the group, huh? You can double differentiate, but that will only check whether it's a maxima or minima, right? But you still have to go ahead and find those x's. And अच्छा, so all of you know how to find those x's, right? So how do you find that? बेटा एक बारी देख लो. You can take 2 common और यहाँ पे आ जाएगा x cube minus 6/2 x minus 5/2 equal to 0. ठीक है, तो यूजुअली क्या होता है, वट एवर इज योर कॉन्स्टेंट यू ट्राई टू चेक एट दैट. तो जैसे कॉन्स्टेंट इज 5/2, माना आई विल चेक एट प्लस माइनस 5/2. एंड क्योंकि 5/2 इज नथिंग बट 5/2 into 1, तो यू कैन चेक एट प्लस माइनस 1. एंड यू कैन चेक एट दिस मेन फैक्टर, माने यू कैन चेक एट प्लस माइनस 5. तो इन एक्सेस पे यू विल चेक द वैल्यू दैट इफ एट ऑल कहीं पे ये जीरो हो रहा है या नहीं हो रहा है. So at these x's you will check whether anywhere it is becoming zero or not. And if it is not becoming zero, कहीं पे भी जितने ये जो भी हमने x's यहाँ लिखे हैं, अगर कहीं पे भी जीरो नहीं हो रहा, so you will simply go ahead and say that it cannot be factorized, right? So no such x exist, no such x exist, and then there is no stationary point. That's the answer. So you have to first learn how to factorize. माने इतनी देर में तो अभी तक आपको factorize कर लेना चाहिए था. To factorize, you look at the constant. आप इस constant के पहले factors create करते हो. So if it is -5, it is -5 into 1, 5 into -1. And if I take 2 common, then I get additional. इसको I can rewrite this equation as -5/2. तो plus minus 5/2. तो only at these 6 x's, I will check this equation. And I will see कि कहीं पे ये जीरो हो रहा है या नहीं हो रहा है. I don't know really how you got √2. √2 यहाँ पे नहीं आएगा. रैशनल फैक्टर हमें देखना है बेटा. I think there will be either one of these as rational roots or no rational root. तो you will check at these. और अगर इनमें से एक पे भी जीरो नहीं हो रहा, so you simply say no maximum or minima exists. ठीक है. And another thing you can do here. If you understand, I hope ये first part clear हो गया. Now, if you look at a function, suppose मैं एक function को देख रही हूं, and I identify that that function is strictly increasing function. अगर मैं ये पता कर पाऊं कि ये function strictly increasing है, in whatever interval is given to me. Suppose ये function ऐसा कुछ बनता है, it's increasing function. तो it means कि at the less x it will have the least value, and at the highest x it will have the highest value. Then also I am sure कि ठीक है, at x equal to 4, this function will have the highest value. Similarly, for example, if I know that this function is a strictly decreasing function, suppose एक ऐसा function दिया हुआ है जो strictly decreasing function है in some interval. ठीक है, again suppose यहाँ पे interval मुझे कुछ दिया हुआ है a to b, and I know that this function is strictly decreasing उस interval में. Again I can say कि ठीक है, a पे उसका highest value रहा होगा and b पे उसका lowest value रहा होगा. So sometimes you don't even have to factorize. आपको ये सब करने का जरूरत नहीं है. You look at the properties of the function. If the function is strictly increasing or strictly decreasing, तो then also you can use the, अगर strictly increasing है in a to b, in the space a to b, if it is strictly increasing, तो b पे it will have maxima and a पे it will have minima. And in a to b अगर ये strictly decreasing है, तो in b it will have minima and a पे it will have maxima. So sometimes you don't have to factorize, you don't have to do anything with the function. बस देख लो कि क्या function increasing है या decreasing है या नहीं है. And what's the property, कैसे check हो सकता है कि function increasing या decreasing है या नहीं है. So increasing means that when you find f dash x, it is greater than 0. The function is increasing. And decreasing का क्या मतलब होगा? Decreasing would mean that when you find f dash x, the function is less than 0. So if the function is strictly increasing or strictly decreasing, then also I can go ahead and I can answer those questions. I'll give you an example. जैसे, let's say I give you the function, बहुत basic ले रही हूँ, fx is equal to x square in the interval 0 to 10, both included. अब this fx is equal to x square मुझे पता है this is a parabola. And when I go ahead and when I plot this, ये ऐसे बनता है. Okay, let me make it first this and then I draw the axis. This is like this. Fx is equal to x square. But I am told that the interval is 0 to 10. Man, I am told कि interval है 0 से लेके 10 तक. So I know that in the interval 0 to 10, this part will not exist. मैं सिर्फ 0 से 10 की बात कर रही हूँ. And in 0 to 10, the function is increasing. So it means that at 0, the function should have a minima. And at 10, the function should have maxima. So in this case, I don't really have to solve. By looking at the property of the function, I will know whether there will be maxima or minimum. Is it clear? So sometimes this property may turn out useful for you. Okay, so अब ये question I leave it to you to check.